Hi, welcome back. So far we have understood, how channels and peers are, the most building blocks of any Hyperledger Fabric-based system. So going further, we'll be talking about, how these channels and these nodes are governed using policies in a particular Fabric-based network. So So what happens here is, and this particular piece is somewhat different amongst different blockchain frameworks, right? So in Ethereum, it will be different, where you actually use the ownership of token to govern a behavior, right? And here, the network is governed using a policy which is agreed upon, in the consortium, and these policies encode each organization's right. So, like in a constitution, you have documented the rights of, let's say, various common bodies, right? Similarly, in the policy for a fabric based network, you encode each organization's right. You also encode what organizations must agree if there has to be any change in the network, right? So you all have to document that, right? And the transition between constitutions is possible between, with an agreement. So let's say you have a policy in place right now, policy version v.1, right? And let's say there is a change in the business process which requires an updation to the policy. So now you have a version 2 of the same, of the policy document. So there should be, so the transition is always possible between version 1 of the policy to the version 2 of the policy, right? And Fabric uses identity and policy throughout, and they are basically used to define the relationship between various organizations, right? So it's really important that we understand the concept of, the various policies, that basically are used in this. So let's say if something is basically submitted for a change, right? So all organizations must agree to any change in the network, right? So, or another probability can be a majority of organizations must agree to the change in the network. So, let's say in this case, there are 4 organizations, right? So, at least overall there are 7 organizations, right? So, at least 4 organizations must agree to the proposed changes in the system. And then what other option can be? Majority of organizations, including a particular organization, must agree to a change. So this particular organization can be, one which has the highest stakes on this network, something like that, right? So let's go ahead and try to understand the ledger, right? So from a fabric point of view, ledger comprises of 2 data structures. One, a block is chain, the blockchain as we call it, and second, the world state, right? So blockchain is the immutable log of transactions which are shared across different peers in a network, right? So this is where we talk about immutability, right? Where anything that you record on a blockchain ledger in form of a transaction is stored as is, right, and cannot be edited, changed, and all. And second data structure is the world state, which holds the current value of a particular asset, which is derived from the blockchain, right? So if you see the infograph on the right hand side there, right, which talks about a peer P1, which actually has this, is having 2 data structures there. One is a blockchain, the ledger that you see towards the top, the blocks which are connected to each other, and second, the world state. So if you see the distinction there, the blockchain stores the historical value of transactions, right? So, for example, there is a right transaction, which talked about some status update of an asset called card2, which was signed by org1, right? So that's what is stored in the blockchain, right? And the world state has the current value of the same asset, which can again be updated by some other transaction, right? So let me give you another simple example to understand this. Let's say there is a car one. The initial owner of the car is Bob, okay, and after the owner Bob sells the car one to, let's say, Tom. So the ownership of car one, which was owned by Bob, goes into blockchain as a ledger entry there, and the current owner, which is Tom, actually gets recorded in the world state. So world state will say car one is equal to Tom, and in blockchain you will have Bob as the earlier owner of it, right? Smart contracts or chain codes are the way to read to or write from the the world state. Like they're like stored procedures from a database point of view, right? We have application which submits the transactions, and which asks the network to either to invoke a smart contract with certain parameters. Transaction order and output is agreed by a network through consensus. We already talked about that. World state may be complemented by private data collections as well, right? So it's really important that we sort of understand that piece there. So, we talked about this. This is a typical example of a ledger which basically shows private and public estate, right? How a particular thing is available, right? It also actually shows the concept of constraints, triggers, and views, right? A constraint can be anything like, for example, all cars have a owner, right? Um, in this particular DMV org, right? And or there can be a trigger of a sort, like notify on a particular stolen car. So in the police org, see this in this one. So there can be a trigger which can be for notifying for any stolen car there, right? And they can be similar such ones, right? So it basically shows about the typical view of a ledger, right? Uh, Another could be, in the view, it can be like show all the cars which are built before year 2000, right? And this is in the public state, right? So either of the ways it's possible. So let's try and go further, right? So the basic structure of a client application is the application interacts with the Fabric network. Now, how does it interact? If you see there, so this is the application, right? This is actually connecting with the various peers, right? So it connects to a gateway using an identity from the wallet, right? So it's really important to understand that, as I said earlier, identity is key here. We're talking about a permissioned network, right? Where there is somebody who is providing you. So how does this permission come? Permission is basically granted through a identity, right? That's typically how you see this. And so after you connect to an available network, and to a particular smart contract, see this is smart contract here. The application submits the transactions and checks their responses. We'll see this in detail in our subsequent slides. And once we have checked it, the application has checked it, it disconnects from the gateway. The entire, work of connecting with the network, having all this back and forth, this all or consensus is basically hidden from the programmer, right? This is all are done through the SDK. There are multiple SDKs available from a Fabric point of view, right? So we'll see how this happens. So let's see how in a particular application, how it queries the ledger, right? Now this is the most simple operation that an application performs. Okay. Now in this, we are looking to introduce a method called evaluate transaction, right? So we have this evaluate transaction method, which causes a smart contract to be run. Okay. So in this particular scenario, we are running it, but we're not sending the results to the ordering service for inclusion on a ledger. We're not doing that here. It's basically only from our understanding point of view. So client applications calls the method to run a smart contract called evaluate transaction, as we said, right? So this client, this gets sent to the peer and is run. Now the output gets returned to the client. You see this coming back to the client here, right? Other organizations can also do the same thing, query the same ledger using peers from their own organization. Now the point here is we are running the method, but then we are not sending the results here to the ordering service for inclusion. We'll do that in the next on the next slide here, right? This is where we typically see how we do this. So let's say application smart invokes a smart contract which is installed on the endorsing peers. So typically we have committing peers, we have got endorsing peers in a blockchain in a Hyperledger Fabric environment, right? And then we have the ordering service, which basically groups all these endorsed transactions into blocks and then distributes it to all the peers in that particular network. Once a peer receives it, the peer validates every transaction using the endorsement policy available on the in the smart contract. So let's try to see this, because this is where we see the entire flow happening. So we have this submit transaction method, right? When and this is basically submitting the transaction submission. It's using the API submission API, right? The proposal goes to all the endorsing peers. So as I said, endorsing peers are the one which endorse the transactions, right? So they have a smart contract, the S that you see, the smart contract is running, which has all the policy that we have already discussed for the endorsing of a particular transaction, right? Once the endorsement node executes the proposal, it basically creates a read-write set, the RW set, and this is signed by the endorser, which is creating it, right? The RW set. The RW set is basically sent back to the SDK, right? And then the SDK, what it does is it sends the RW set and the signatures of all the endorsers, right, to the ordering service. Here, O1, O2, O3. This is basically a high availability ordering service, right? And not just this particular application, there can be similar other applications in this overall bigger network, which will be sending their request to the ordering service. If you see there, we are seeing, getting this multiple inputs coming to this ordering service, right? Now, at some point, a block is created, right? And which is nothing but a set of RW sets, the read-write sets, which are basically provided, right? The block is sent to each peer on the network, right? So the block which is created by the ordering service is sent on the network to all the peers. In this case, P1, P2, P3, P4, and all of these. Now each peer validates each RW set, the read-write set in a block, right? Here, the peer looks for two things. One is the read-write set is still valid. So from the time of getting endorsement till the time the read-write set has come to the this peer, is it still valid based upon, how does this work? It's checked upon based upon the world state. So it will validate the data on the world state, which is the current value of the set, right? And two, has the RW set been applied correctly? So these are the two things the peer will validate against, right? So the RW set that passes these checks are applied to the world state, right? And if there are any such read-write sets which are not valid, they're actually recorded in the ledger, but then they do not change the world state, right? So let me explain this again. So once the peer validates the RW set, these checks are updated and applied to the world state. A quick example. Let's say in the case of a car ownership that we talked about, right, that the car originally belonged to Bob and the car got transferred to Tom. So in this case, the car in the previous slide that we discussed, the current owner of that car was Tom. Let's say the car is again being sold to somebody called Smith, right? So when that endorsement has come to the peer P1, P2, P3, and so on, the RW set basically consisted of things. What does it consist? It consisted that the current owner is Tom and the new proposed owner is Smith, right? So what we'll do is peer 1 or peer 2 will actually validate the data RW, the read-write set, against the data available in the world state and see whether the current asset owner is Tom or not. If it is Tom, then they will update the owner of that car as the owner to be Smith, right? And the historical owner, which is car owner, is equal to Tom. Actually, that value goes into the blockchain, and the world state is updated by this new owner value called Smith, right? So that's how typically the read-write passes these checks, and the application, once this is done, gets notified about this update which has happened in the blockchain-based network, right? So this is how, if you see, all the typical peers, the ledgers that they have actually get updated by the application, by the transaction submitted by the applications. Okay. So let's try to understand, right, the application gateways. Now, gateways are very powerful tool, right? They isolate the business logic from the network topology, right? They actually allows client applications to focus on what and not the how part of it, right? And uh, from a single gateway, you can discover the smart contracts that are available, for that particular peer. And when you discover a contract, you can then issue transactions against it. You can work with multiple networks or contracts at the same time, right? So gateway handles all the interaction between the network, right? So if you see in this infograph, we can see how a particular gateway interacts with peers connected on this channel. See this? The entire conversation is so peer returns the available network services, right, to the gateway, and finally you have the gateway object. The client SDK interacts with the channel services. Uh, yeah, so this infograph basically talks about how all the instantiated smart contracts are accessible on the channel, right? And application can submit and evaluate multiple transactions, and they can also connect to multiple gateways. An application can convert to multiple gateways at given point in time. Okay, so let's try to move on to the next part, right? So we have already understood that peers connect to the network using identity, right? Now, identity is given by X5.509 certificates. These are, uh, it's a digital certificate based on International Telecommunications Union X5.9, 509 standard, which defines the format for PKI certificate, Public Key Infrastructure Certificate, and they are basically used to manage identity and security in both internet communications, network computer networking, and all, right. So here, each of these are issued a X.509 identity, and this is given by the organization certificate authority, right. So if you see, each org here, org 1 has a certificate authority, CA1. Org 2 has another, certificate authority, CA2. Org 3 has its own certificate authority, CA3, right? Similarly, ordering service have their own certificate authority, right? So the component uses, the identity basically to determine what is the organization role based upon the identity certificate. And this role determines the level of access it can get to the resources available on that particular network. So whether it's a read access or a write access to the ledger, all that is basically controlled by the certificate, by the identity. Yeah, and wallets store all these identity which are available. Application can use multiple wallets and identity, depending upon which hat are they wearing, right? So same peer can be acting as an endorsement node or an endorsement peer for one particular business transaction, and it can be acting as, a committing peer for some other business transaction, right? So this is absolutely fine, the approach of, working things. Now, membership services provide, MSP, membership services provider, uniquely identifies the various identities and roles, for a particular channel, right? And application, as I said earlier, can connect to multiple gateways with identities, right? And if you see here, it basically provides for how all one, provides for these certificates using wallets, right? And you have this certificate authority which is, connecting to this gateway here, right? And then the multiple keys or the identities available which are stored in the wallet. Let's move on to the next part, which basically talks about how these gateway connections can be customized, right? So from a single gateway, you can discover, the multiple contracts that are available to you. So when you discover a contract, you can then issue transactions against it, right? And all of them are, you can actually work with multiple networks on contracts at the same time, right? With multiple connection profiles. So you can see gateway here, it can connect to, multiple applications with different connection profiles here. Okay, so this is typically, a overall client application example where, we see how an SDK provides for a wallet, identity, gateway, network, contract classes to access the smart contract, right? Then it basically does a query, ledger query using a contract.evaluate transaction or doing an update using contract.submit transaction. Now, consensus is managed transparently by the SDK, right? And applications only focuses on what, not the how part of it, right? So we already understood that earlier. Gateway options parameterize the typical interactions, right? Wait for any or particular peer in an organization to confirm something, right? So this is typically like a client application, how it looks like, right? Um, and Yeah, there can be multiple ways to do it. Um, in Hyperledger Fabric, which is actually written in Golang, there are SDKs available in multiple languages. You have JavaScript, you have of course you can use Golang, Node.js, right, to write the smart contract. Okay, there are a couple of development tutorials available, and there is a batch program also available. I would recommend, if you can go to ibm.com/academic, ibm.biz/academic, which is a platform for IBM Academic Initiative, under which there are a lot of courses available on a blockchain for learning blockchain. There are a couple of digital badges also available on blockchain and other technologies, which you can leverage from there. Um, yeah. So with this, we'll finish this module here. We'll look forward to seeing you in the next lecture. Thank you.